Alright, now let's use the fundamental identities that we just talked about in the last video to do some problems. We're going to find the exact values of all 6 trig functions of some angle theta. Again, we don't know the angle, but we know its cosine value is -1/4, and we know that its tangent value is greater than 0. Okay? Alright. Finding exact values means not using a calculator. You can use a calculator to find trig values, but that's not what we're going to do here. Alright, so there are 6 trig values we want to find. The first one we know, cosine of theta, is -1/4. Now, the tangent of theta being greater than 0, what does that tell us? Well, tangent theta, we already know because of our identities, is the same thing as sine theta over cosine theta. And we know that the cosine theta is negative, right? Because it was given to us. If tangent is positive, then that means that the sine theta must also be negative. So where on the coordinate plane, which quadrant has both the sine value and cosine value negative? Well, since they're x and y, that's where x and y are both negative. So my angle theta is somewhere here in quadrant 3. Again, I don't really care what it is, but I know that it lands in quadrant 3. Okay? I also know that its sine value is negative. Alright, so how am I going to find the other trig values? Well, I'm going to use my identities. There are 2 right now of the identities that are going to work well for us. The first is cosine squared theta plus sine squared theta equals 1. And we're also going to use the idea that secant theta is 1 over the cosine theta, right? Why use these? Well, they both involve the cosine, and they both have just one other trig value in them. So we can plug in for the cosine value and solve for that other trig value for both. Now, cosine squared theta, I know that cosine is -1/4. So I'm going to square that, right? Sine squared theta, sine theta is my variable. If I square -1/4, that's the same thing as 1/16. Subtracting that from both sides, well, 1 is the same thing as 16/16. So 1 minus 16/16 is, -15/16. I'm sorry, it's +15/16. What am I thinking? And then that means that sine theta is plus or minus the square root of 15 over 4. Square root of 16 is 4. Now remember that the sine value, we already said, is negative. So what that means then is that our sine of theta will be negative square root of 15 over 4. Okay, so that's one value. One of the 6. So now we have 2 of the 6 values. Now secant theta is just 1 over cosine. Well, cosine is -1/4. 1 divided by -1/4 is -4. So here's third trig value. Okay? So we need to find 3 more. What do we need to find? How about cosecant? We know that cosecant is 1 over the sine, and now that we have sine, we can find this one. Square root of 15, negative square root of 15 over 4. That's the same thing as -4 over square root of 15. Rationalizing that gives me -4 root 15 over 15. So that's my cosecant value. So we have cosine, sine, secant, cosecant. The 2 that we don't have are tangent and cotangent. Well, luckily, tangent and cotangent both involve sine and cosine. Turns out that tangent is sine over cosine. I found that the sine is negative square root of 15 over 4. and that cosine is negative 1/4, which was given. The 4's will cancel, and 2 negatives become positive, and you get square root of 15. Remember that the original said that tangent theta was positive or greater than 0? Here we go, square root of 15. Okay. And what's cotangent? Well, we could do 1 over tangent. We could do cosine over sine. How about 1 over tangent, since we just found tangent? That's 1 over the square root of 15. Well, let's rationalize that, which means we will get square root of 15 over 15. All right, so we found all 6 values. We found the values of all 6 trigonometric functions. There's one more set of properties in this section that we need to talk about, and those are the even-odd properties. Recall what even and odd means? Even means that something is symmetric over the y-axis, and odd means it's symmetric around the origin functions. Okay. So the even-odd properties look like this. If we take the sine of the opposite of some angle, that's equal to the opposite of sine of that angle, right? This is like the equivalent of plugging in a minus x and getting, plugging in a negative y and getting y back. Yeah. Cosine of minus theta is not minus, it's positive cosine theta. So in this way, sine is odd. Hold on. Sorry about that. Cosine is even. And it turns out that tangent is also odd. It's an odd function. Because sine is odd and cosecant is just 1 over sine, then that means that cosecant is odd. Because cosine is even and secant is 1 over the cosine, then, cosine is even, and secant is 1 over the cosine, then secant is even. Cotangent, of course, as you might think, is going to be odd, right? Because tangent is odd and it's just the reciprocal of tangent, right? Why does this work? Well, I'm going to show you a picture just for sine and cosine, and then the rest of them come from that. Right, so here's my unit circle, and I'm going to take a point P, x, y, and this angle theta, right? Let's look at the angle, oopsie, hold on, let's get rid of that. Whoa, that isn't really what I wanted to happen, but okay. Let's put 1 here now. And let's look also at minus theta, going this way. Yeah. This point P will have the same x-coordinate as the point P above. Actually, let's call this point Q. But it's going to have the opposite y-coordinate, right? Because we're reflecting over the x-axis. Okay. So what's sine of minus theta? Well, that's minus y. And what's sine of theta? Well, that's y. So we have, notice we have, if I want to say minus y equals minus y, I can replace 1 minus y with sine of minus theta, bring down this negative, and replace this y with sine theta. So basically I'm saying that the sides are opposite values for these two angles. right? So similarly, or not similarly, the other way, cosine of minus theta, right, is x. And cosine of theta is also x, right? So that tells me that cosine of minus theta is the same thing as cosine of theta, which is what we said above, which is the same thing as being an even function, right? Okay. We can use these properties to find trig values of all the functions, and there's some really good examples in the homework and in the book.